Hey, it's Clarissa enumerated here. So the inverse of cosine for the hyperbolic function is equal to ln of x plus square root of x squared minus 1. And for the derivative, for ln of x plus the square root of x squared minus 1, we have it equal to 1 over x plus square root x squared minus 1 times d over dx of x plus square root of x squared minus 1, which is equal to 1 over x plus square root x squared minus 1. And we multiply square root of x squared minus 1 plus x over square root of x squared minus 1, which is equal to 1 over square root of x squared minus 1. For part B, where you make y be equal to the inverse tangent, the hyperbolic function. So tangent of y is equal to x. We differentiate to get secant square of x for y dy is equal to dx. So we get dy over dx to be 1 over secant square. So dy over dx is equal to 1 over 1 minus and tangent square, which is equal to 1 over 1 minus x squared. For part C, we're going to allow y to be equal to cosecant inverse. And we get cosecant is equal to x. We differentiate implicitly, so negative cosecant y cotangent hyperbolic function of y dy is equal to dx. So we get dy, a value for dy over dx, we just substitute, which becomes equal to negative 1 all over cosecant y plus or minus square root of 1 plus cosecant square of y, which is equal to negative 1 over x times plus or minus square root of 1 plus x squared, which is equal to negative 1 over absolute value of x square root of 1 plus x squared. For part D, we allow y to be equal to secant inverse So secant of y is equal to x. So we get dy over dx to be equal to -1 over secant over tangent. We're just going to substitute tangent, the hyperbolic function y, for plus or minus square root of 1 minus secant square. So we get -1 over the hyperbolic function of secant plus or minus square root of 1 minus secant square of y. And this becomes equal to -1 over x plus or minus square root of 1 minus x squared. So looking at the domain, we could just use the positive root since it's 0, -1 included.